Welcome! Our projects look at improving the parking lot management system for apartment buildings. In many countries, the parking lot management system for apartment buildings are rather simple. When visitors come to visit the house of the residents, they normally have to ring the residents by the telecom here, and the residents will unlock the gate to the shared parking lots by answering the telecom with a single button press. But that process could lead to the rise of tailgating, where this red car here will closely follow the car in front of it to get unauthorized access to the building, which is a major security risk. Furthermore, while parking for people with disability exists, but most of the time it's largely not implemented or implemented with limited functionalities, and sometimes it's just a simple sign here like this. And furthermore, a lot of the system doesn't generate reports to collect data, therefore the parking lot managers will have no ideas about what's going on or the current system status or the parking lot traffics. And now we propose a low-cost improvement to several existing parking lot systems. We'll be using an ESP32 as the main controllers, and we will add an extra servo gate at the back here that will actually close when a car is waiting for access. This will prevent tailgating because when the main gate is open, this car cannot move forwards. The same servo is also added for the exit direction as well. To help with parking for disabled people, we'll use the sonar sensors that will detect when the car is close enough, and if it is close enough, this buzzer here will output a long beep indicating that the car has reversed correctly into its spot. There will be two IR sensors on each side for car detections, two buttons to unlock the main gate just like the button on the telecom panels of the residents. We'll also add a humidity and temperature sensors for environment monitorings. We have an OLED to display several system status, which will also be transmitted to an InfluxDB database and visualized by Grafana. And to change some system parameters such as the Wi-Fi network to use or channel to scan or gate speed, we'll be using MQTT to remotely control those parameters. Our solutions bring several benefits. First is uses dual gate mechanisms to create a buffer zone to prevent tailgatings, significantly improve security and safety for the residents as well as traffic control. Remote control can prevent on-site injury for staff. Secondly, our parking assistance system is quite special and rarely seen implemented elsewhere in the traditional parking lots. It uses low-cost sonar sensors with decent reliability to detect distance, and this will both improve safety and be a major helping hands for people with disabilities. And it also works on older car model as well that doesn't have a good network of sensors. Because of that, our design successfully encourage inclusive design in automations and IoT that maximize benefits for all user groups. And financially, the low-cost modification and sensors will allow implementations in residential areas on a tight budget. Furthermore, the IoT upgrades will also allow staff to not be on site 100% of the time. It will be a major boost to their efficiency.
Here's a quick system demo. When I place the object in front of the IR sensors, the back servo will close to prevent tailgating, and when I press unlock, main gate open and the object moves through. After that, the gate can reset. The sequence is similar on the exit direction as well, so when I press unlock, that servo will open and object moves through. The system is robust with good reliability and repeatability, mainly due to all sensors readings are correctly debounced. Here I have attempted several entries and exits, and the system behaves as expected. This OLED display shows temperatures, humidity, servo angles, number of cars, and whether the assisted parking spot is taken or not. For parameter configuration over MQTT, here we tell the system to return the scan result of Wi-Fi channel 6, which then be displayed on the Explorer software like this. We'll also change the servo speed to 130 and close time to half a second, and you can see the changes being applied here. We also send some sensors readings to InfluxDB, and the values can be seen in the red box here. We use Grafana to visualize the database, and it's currently graphing the humidity, temperatures, Wi-Fi signal strength, and the number of cars. And here shows the integration of all subsystems including sensors, actuators, InfluxDB, and Grafana. For MQTT, please revisit 3 minutes 45 seconds for better demonstrations. And as you can see, when the car is moving in and out of the gate, Grafana will update the chart accordingly.